Hi everyone, myself Yash Kond. I am currently studying in Sri Santa Gajan Maharaj College of Engineering, Chegaon, and this is my internship project from Emertxe, and my topic is washing machine simulator. This project is done on PICSIM LAB, and this is the table of content of my project. First, introduction. Second is embedded system and its components, software use, PIC microcontroller, Emertxe variable description, project demonstration, and sample outputs. This is the table of content of my uh, presentation in the above slides. This is the introduction of my project, washing machine project. Washing machines are used to reduce human labor and save time. Washing machines have an important place in the modern society. Nowadays we can see various kinds of washing machines. Customers wants to have fully automatic machines instead of semi-automatics. In this project we have built a simple washing machine prototype using PIC 16 F877A microcontroller. This is the introduction of my project. Second subtitle of my content is embedded systems. In which I have given the definition. It is a combination of both hardware and software electronics gadget to do a specific task. Example of embedded systems include microcontrollers in household applications like washing machines, industrial control systems in manufacturing plants, navigation systems in automobiles, and medical devices like pacemakers and insulin pumps. This is the brief diagram of types of embedded systems. It is divided into based on performance and functional requirements, and second based on performance of microcontroller. Based on performance and functional requirements, it is real-time, network, mobile, and standalone. And second based on performance of microcontroller, it is small scale, medium scale, and sophisticated. This is the types of embedded system we can see around us, working in many projects and various gadgets. You can simply take an example of any of this and imagine a real any example around you. You can easily understand, or you can easily get the application of each of the types of embedded system, which is based on performance and functional requirements and based on performance of microcontroller. I take this image from the engineeringprojects.com. The next slide is of components of embedded systems. These are the components which are very important in embedded system. First is the important main part of embedded system is CPU, controller processing unit. Then it connects the whole embedded system parts such as memory, DA conversion, actuator, auxiliary system, diagnostic port, human if port, AD conversion, FPGA, digital hardware, sensor, and software also. And the sensors such as electromechanical, backup, safety, and environmental environment. DA conversion is connected to actuators, and AD conversion is connected to sensor. Basically, AD converter means A to D means analog to digital converter, and DA conversion means digital to analog conversion. These are the important components of embedded system where which is used in us any of the embedded system around us. Without this component, an embedded system is totally incomplete. You can go one by one of these components and search. You can get the basic definition of all these components of embedded system. These components are very important in microcontroller. This is the next slide of PIC microcontroller. The first is to build this project. We are using PIC 16F877 microcontroller. The specification of this PIC microcontrollers are: it has 40 pins, it has 5 ports in total: port A, port B, port C, port D, and port E. Port A is of 6 pins, port B is of 8 pins, port C is of again 8 pins, port D is of 8 pins, and port E is of 3 pins. It supports serial communication for it has 2 pins, TX and RX. It can also supports SPI protocol, and we have oscillator frequency range from 4 megahertz to 40 megahertz. SPI, the full form of SPI protocol is serial input output protocol. In this project I use the following softwares. The first is PICSIM LAB, second is MP Lab X IDE, third is XC9 compiler, and fourth is PIC Genius PIC 16F877A MC board. PICSIM Lab is a virtual environment for compiling the embedded systems projects. This is the symbol this is the symbol of MP Lab XID, which I take from Google. You can go you can go through all the 4 softwares that I have used in this internship. Now next slide is about embedded C. C is important for embedded system due to its efficiency, probability, and low level access, enabling precise control over hardware and optimal resource utilization. Data types and variables. Understanding different data types and variables declarations for efficient memory usage. Pointers and memory management. Manipulating memory addresses and accessing hardware registers directly. Control structures. Implementing decision making logic and repetitive tasks. Functions and modular programming. Encapsulating reusable code blocks and facilitating modular software design. Preprocessor directive. Manipulating source code before compilation for defining constants and conditional compilation. This is the definition and all basics about embedded C, which I take from Google itself. You can also go through embedded C on Google and you get all the basic information about embedded C, how it works, how it is important in embedded system, and etc. You can go through one by one point from this slide and easily understand by yourself also how the embedded C is working, how it is defined. Embedded C is the backbone of embedded system software, because of embedded C we can easily dump any code in the embedded system, and it can work according to it. These are the peripherals First is LED. Light emitting diode is a semiconductor device that emits light when an electric current passes through it. LEDs are commonly used in various applications. LED is an external device connected to microcontroller port. A port is interface between controller and external peripherals. LEDs are commonly used in various applications, including in indicators, display, uh, illumination, and as components in electronic system due to their efficiency. This is the diagram or schematic of LED which I take from Google. LED means light emitting diode. This is second tactile switch as digital keypad. In microcontrollers, switches are often used as inputs to control the operation of the device or to interact with the user. When the button is pressed, the switches turn on, and when the switch is released, the switches turn off. They are typically connected to specific input pins on the microcontroller, enabling the detection of switch state cases. Third is CLCD. The full form of CLCD is character liquid crystal display. Crystal display is a flat panel display technology that uses liquid crystal to modulate light and display images or text. LCDs operate by modulating light through liquid crystals controlled by electrical signals. Important pins for interfacing with an LCD include power, VDD and VSS control, RS, RW and E, and data lines D0 to D7 along with the contrast control pin. These are the interrupts. Interrupts is microcontrollers. Interrupts in microcontrollers are hardware or software signal that temporarily suspend the normal program execution to handle critical events or external stimuli. An internal or external requires to the MPU to stop the processing. Third is attends to the request, and fourth there are two types of interrupts. First is hardware interrupt and second is software interrupts. You can also search more about interrupts by yourself also on Google. You get lots of information on interrupts. The next slide is of timers. Timers in microcontrollers are versatile hardware modules used for measuring time intervals, generating precise timing signals, and implementing time crucial operations. They can be configured to operate in various modes, including timer, counter, pulse, width modulation, and capture compare modes, catering to a wide range of timing requirements. Timers often feature adjustable prescalers and reload values, allowing for fine-grained control over the timing resolution and period, essential for applications such as motor control and or other embedded system. Next, we will go through the project from PICSIM Lab. This is the schema. This is the diagram of schematic of washing machine on PICSIM Lab. Here are the various options. We By using file option, we can dump our code in this schematic. Now you can see on the screen that in the left side in the upper left side we can see the options that if we press 5, the washing machine will starts operational. First, washing machine programs wides, we can tab enter, and we can see various options that we can see on real time, means we can on the real time washing machine and on the schematic as well. These are the next level various options: dry only, wash only, daily, aqua store. We had done this programming using Emertxe only. If we take next, we means enter, we can get various options. This day we can see water level is low, medium, high. We can choose any of by entering up arrow or down arrow and press enter. Press switch SW5 to start. Here program wash only, we have started the washing machine. We can start by 5 and we can stop the program by 6 minutes. We can stop the washing machine by pressing 6. We have applied the timer for say 40 seconds. We can see it is reversing by 40 seconds, the 26, 25. We can see the washing machine is working properly. Like this only the actual washing machine in our house works. Basically this is on the schematic, but the actual washing machine also works like this only. Because of this the PICSIM LAB software is very important for we can demonstrate any of the embedded system software on this PICSIM LAB by drawing schematic and dumping code in that and perform operations. Thank you for watching my video. Thank you very much.